Hello, and welcome to IWRA's first online conference, Addressing Groundwater Resilience Under Climate Change, that is being co-sponsored with the International Association of Hydrogeologists and UNESCO Intergovernmental Hydrological Program. I can see that people are still logging in, so I'll speak rather slowly as we get started to allow more people to join. My name is Renée Martin-Nagle, and it is my honor and pleasure to be your chair and host for this opening session. I am joined in co-hosting by Mary Trudeau. In addition to serving as treasurer of IWRA, I also take special pride in being involved with the groundwater community, which those of you who are involved in the community know is a fabulous group of experts who care deeply about water resources on this planet. We believe that you will find the program to be content-rich and filled with speakers who are global experts on groundwater. The fact that more than 2,200 people have registered for this program proves that as climate change requires greater dependence on groundwater, an in-depth review of this critical resource is both timely and necessary. During this opening session, you will be hearing from the sponsors, and we also have keynote presentations from Famiglietti and Villeroth. Before starting the program, we have a few housekeeping messages for you. You are invited to submit your questions in English via the Q&A button, which is at the bottom of your screen. In this session, we will address your questions as much as possible during the Q&A session after the keynote speakers. You will only see each question once it has been answered, either verbally or in writing, when the question will be displayed for everyone to see. Since we have such a huge audience, we may not have time to answer all of the questions that we receive, but we will aim to collect written responses from presenters throughout the conference to place on the conference website following this event. Please note that the chat box is disabled during the sessions. However, we ask you to keep an eye out for any useful messages that may be shared in the chat box from the organizers and moderators. Our attendees hail from around the globe in many different time zones. To enable as many people as possible to hear the sessions, the conference is being recorded, and we will make the recording available both on the IWRA website and on the conference website as soon as possible. If you experience any technical problems, please visit the Zoom Help Center online or send an email to online.conference@iwra.org to request assistance. And with that, it is my great pleasure to introduce our first speaker, Gabriel Eckstein, who is president of IWRA, professor of law at Texas A&M University, and director of the law school's program in natural resources systems. Gabriel?
Thank you so much, Renee. And I want to welcome all of you, all of the attendees, all of the speakers to this gathering. Thank you all for joining us for this exciting couple of days of learning, sharing, and engaging. Before I begin, I want to send a special thank you to a number of organizations and individuals for their tremendous support in planning this event and for making this unique conference possible. First, I must thank UNESCO, as represented by Dr. Shamila, Nair-Bedouelle, Assistant Director General of Natural Sciences, and Dr. Alicia Arali, Chief of the Groundwater Systems and Settlements Section of the International Hydrological Program. We especially want to recognize UNESCO for underwriting the conference and for allowing us to make the registration fee free for everyone. In addition, I want to thank the International Association of Hydrogeologists, represented here by Dr. David Kreamer, the new president of the association, and the Institute for Water Education at Delft, represented here by Dr. Tibor Stigter, for their unbridled cooperation, support, and encouragement in organizing this event. Further, I want to thank all of the members of the International Scientific Committee for their tremendous work in planning the agenda and the program. And I want to especially highlight the tireless efforts of Doctors Jean Fried, Jacques Ganoulis, and Tibor Stigter for their leadership in guiding the whole event, as well as their commitment to ensuring the incredible high quality of the program. And lastly, but certainly not least, I have to recognize all the folks behind the scenes, Callum, Ignacio, Alice, and Monica in the IWRA Executive Office, who are responsible for having figured out how to actually organize and run a conference entirely online. This event, this is IWRA's first online conference, has been in the works for quite some time. Long before we ever heard of COVID-19, more than a year and a half ago, planning began with the conversations by various board members with the aim of reaching out more broadly to researchers, academics, policymakers, and practitioners working in the realm of water. In particular, we wanted to provide them with a formal Congress-like opportunity to present their work, especially to those who might not otherwise be able to travel to one of our World Water Congresses. Little did we realize when we launched the idea that no one in 2020 would be able to travel anywhere. But now all of us here are here together, including more than 2,200 of you who have registered for this event, all seeking to share your experiences, to learn from each other, and to seek solutions for the water-related challenges that arise at the intersection of groundwater and climate change. Both of these areas, groundwater and climate change, are of considerable importance to IWRA, but both are effectively invisible forces of nature with powerful impacts that are felt directly by all of us. Making the connection between these two aspects of nature is not always obvious, but it is critical that we investigate and study and expand our knowledge about the linkages between water stored and flowing under the surface of the earth and on which billions of people rely for their daily rations, and the climatic system that supports and is part of the hydrocycle and that is now changing all around us. Accordingly, these are subjects that are dear to the hearts of many of our members, including myself and others on our executive board, who have spent considerable time researching and writing and working to better understand these issues. As an association, we have held a number of webinars on these topics, including on groundwater and climate change, multi-level law and policy perspectives, and on climate change and adaptive water management. We have also published policy briefs on sustainable groundwater development for improved livelihoods in sub-Saharan Africa and on the groundwater and climate change multi-level law and policy perspectives. In addition, our 2020 UNESCO IWSSM case study report project that we are currently managing is focusing on the topic of water security and groundwater. And to this list, I must add that we have an IWRA task force composed of IWRA members focused on the intersection of climate change and freshwater resources. And we are now establishing a new task force focusing on groundwater that we expect to collaborate with the Climate Change Task Force, as well as our other task forces when the research and topics call for cooperation. We're actually now seeking additional IWRA members to join the Groundwater Task Force's Bureau. So if you are at all interested in this task force on groundwater, please do not hesitate to contact our executive office for more information. And lastly, as you will all likely know, the UN has declared the theme of World Water Day for 2022 is groundwater making the invisible visible. Accordingly, we are now preparing for that momentous year with this conference, with other collaborations that we expect to take on with UNESCO, IAH, IHE Delft, and other partner organizations in the coming years, and with additional webinars, publications and policy briefs, and webinars, programs, and other events. Now, having reviewed closely the program on the conference website and speaking with the various session organizers, I can promise you an exceptional and stimulating 2 days of conference sessions. I look forward to and plan to attend as much as I can from my time zone, and I plan to catch up on those that I miss from the recordings. I hope you feel and will do the same. It seems appropriate that IWRA's first conference on a critical climate change issue is being held online, meaning we can maximize participation while minimizing our carbon footprint. Have a wonderful conference. Thank you.
Thank you, Gabriel. And now we're going to hear from Dr. David Kreamer, who is president of IAH, professor of geoscience, and past director of the Interdisciplinary Water Resources Management Graduate Program at the University of Nevada, Las Vegas. Dave?
Thank you very much, Renee, and thanks to Gabriel, Jean, Jacques, and Tibor, and the other members of the International Scientific Committee that represent some of the best groundwater experts in the world. I'd like to add my welcome of the International Association of Hydrogeologists, representing thousands of members in about 130 countries, who are one of the co-sponsors of this event. Groundwater and the springs and wetlands groundwater sustains serve as the lifeblood for living communities. The need for having groundwater is a key element in global resilience to climate change, as a shield against ecosystem loss, as a defense against human deprivation and poverty, and for peace and equity in the world. We're fortunate to have people from all over the world in this conference that have many different languages, but common hopes for our countries and families and the sustainability of our resources. Nelson Mandela once said, "If you talk to a person in the language they understand, that goes to their head. If you talk to them in their language, it goes to their heart." The very language of water and groundwater throughout the world shows its multiple connections and importance in the face of the onslaught of global warming. We know that not all groundwater is liquid. In the northern Canadian province of Nunavut, the Inuit are Native Americans that speak the language of Inuktitut. They have many words for snow, water, ice, but none of them embody the problem of a region verging on permafrost collapse. The melting of the subsurface permafrost means more than just the sinking of homes and the flooding of underground caves traditionally used for refrigeration. It means the release of massive amounts of carbon dioxide into the atmosphere as organic material in the ground is exposed, accelerating climate change. In Australia, the Aboriginal tribes call permanent water Gila and the seasonal water Jumu. In the dry outback, they will approach a dry area known as a soak, push their throwing stick in the ground and replace it with a reed from which they can drink groundwater. In the Zulu language, the word amazi can have several meanings. It can mean water bearer or waterborne, such as waterborne disease. It reminds us that it's not enough to care about water quantity alone, but good water quality is crucial. In Nepal, if you mispronounce the word pani for water, it can mean the word also. And there are many alsos with water and groundwater. The arsenic-rich sediments that erode from the Himalayas are an also that pollutes shallow groundwater in India and Bangladesh. One author called it the greatest mass poisoning in history. Another also is the ongoing international disputes over which nation can lay claim to the meltwater from the Himalayas. In Botswana, the word for rainfall, pula, has several meanings. It can mean blessing. A pula is also a denomination of money in Botswana, emphasizing water's importance to economic growth and spiritual well-being. The indigenous Maoris of New Zealand have a double meaning for water, wei. It can also mean lotion, a soothing substance. And in the landlocked country of Niger in Western Africa, 44% of the population does not have access to an immediate source of drinking water. The native language for the majority of Nigerians is Hausa, and the word for water is Rua. But Rua has a second meaning. It can mean blade, like the blade of a knife or a sword. And indeed, water can be a double-edged sword. It can be a blade of conflict and war, fueling political ambitions. It can be a blade of a plowshare or scythe, bringing harvest and abundance. How we use this blade of conflict or abundance, this soothing lotion, this blessing, is up to us. In the face of climate change, we must address the science, economic impacts, and the political implications of climate change and groundwater. This conference brings together our languages and our voices, sometimes disparate, sometimes common. The International Water Resources Association Conference brings us together to hear each other's concerns and viewpoints as we move forward with solutions, empathy, and resolve. Mandela spoke about communicating with understanding and empathy, but I'd like to end with a quote from George Carlin, who said, "Everybody smiles in the same language." Let's learn and have fun and enjoy this conference and have a great couple of days. Thank you very much.
Thank you, Dave. That was very nice. And now we have a video from Shamila Nair-Bedouelle, who is Assistant Director General for Natural Sciences at UNESCO.
Dear colleagues, thank you very much for giving UNESCO this opportunity. I would like to welcome you all to the online conference of addressing groundwater and the challenges that countries and governments face across the world today. This online conference, which addresses groundwater resilience under climate change, is jointly organized by UNESCO, the International Water Resources Association, the IWRA, and the International Association for Hydrogeologists, the IAH. I wish to thank you, Gabriel and David, for the great cooperation existing between your associations and the UNESCO's Intergovernmental Hydrological Program. Dear colleagues, dear participants, this online conference on the occasion of the Addressing Groundwater Resilience under Climate Change would certainly not be able to take place without your presence, your contributions to enhancing the knowledge of this alternative water resource. We are eager to hear from you the results of your research, scientific research, to learn from your expertise on how to better interconnect and take action on groundwater and the impacts of climate change. In terms of water security across the world, we all know and are aware that the groundwater will play in the future a much more and more important role under any of the different climate change scenarios. And this has already been presented to us, the climate change scenarios, by the Intergovernmental Panel on Climate Change, the IPCC. So therefore, we do here at UNESCO will sincerely support you in all your endeavors. Dear colleagues, since the creation, the UNESCO's Intergovernmental Hydrological Program has led the call for increased international and political attention to groundwater resources, including the recognition of groundwater's vital role in many regions of the world, not only providing a vital source to populations and communities, but also in promoting peace and security among nations. After all, access to water is a key for sustainable development today. UNESCO's Intergovernmental Hydrological Program has earned the distinction of being the UN system's most comprehensive long-term scientific initiative on hydrogeology, and therefore we are delighted to join you in this call. The study of the planet's aquifers, the groundwater resources that they contain, is at the heart of UNESCO's mandate. The IHP has toiled over the years to increase awareness of the immeasurable value of the world's groundwater resources in order to make visible the invisible jewel of the planet, the underground water resources. Planning for improved water resource management under climate change requires us to look well beyond the usual boundaries and to think out of the box, to be more innovative and to be creative, and to continue the transition from considering the traditional water cycles to working with the more complex and social hydrological cycles and how these affect the populations that depend upon them. It is therefore necessary to engage the policymakers and more stakeholders to promote investments, to enhance the role that groundwater resources can play in adaptation measures to climate change impacts, but also to intensively raise awareness on the role of groundwater governance, groundwater resources governance, to involve civil society, men, women, and scientists from across the world, but also those populations who are highly impacted by lack of water resources. Ladies and gentlemen, water is a connector to all the sustainable development goals of the 2030 agenda. And COVID pandemic has shown us the importance of access to safe drinking water and sanitation in controlling the spread of the pandemic. Without water, we cannot even do the simple gesture of washing hands to control the COVID. So considering the urgency to accelerate the implementation of SDG 6, the UN has recently launched the so-called SDG 6 Global Acceleration Framework, which has an important portfolio for data and information, capacity development, innovation, governance, And these are part of the specific objectives of the SDG 6 Accelerator Framework. We are delighted at UNESCO to join this accelerator framework because, as we all know, billions still lack access to safe water and sanitation, and hence SDG 6 is largely off track. But UNESCO, with its mandate, is directly engaged in ensuring the SDG 6 Global Acceleration Framework is implemented by all countries across the world through the education, science, culture, or communication and information. UNESCO, through all of its water family, including the Intergovernmental Hydrological Program, its 169 national IHP committees, the World Water Assessment Program, which produces the World Water Development Report, guiding member states on the trends and access to water, but also the 36 UNESCO Category 2 centers, the 63 UNESCO water chairs, all part of the UNESCO water family, are here at your service and serve as a platform for providing countries the necessary tools to manage water and to manage this resource sustainably. Also, all of UNESCO's water family, which I've just informed you about, is really contributing towards water security and improving capacity in managing also the groundwater resources. I'd like to express my sincere gratitude to all of you, ladies and gentlemen, excellencies, for taking part in this online conference and for sharing with us your experiences. We look forward to disseminating all of these across the world and to ensuring that we really have water change makers across the world. I want to sincerely thank my colleague, Alicia Orley, the Chief of Section, Abu Amani, who is the Director of the Water Division right now on an interim basis. And I want to thank Jorge Hellis, our colleagues here, all those who are engaged in ensuring that the invisible becomes visible. Let's all of us deliberate together and have fruitful discussions on how we can ensure and value groundwater as an important resource to meeting sustainable development needs, sustainable development goals, but especially the SDG 6 and SDG 5, and ensure that no one is left behind. We at UNESCO would like to join you in this journey, and we thank you for giving us an opportunity to be part of this forum. Thank you very much, and I wish you good deliberations. Thank you.
Thanks to Shamila for reminding us that water is a great connector and that UNESCO is connecting all of us through its varied activities in water. And now I would like to introduce Dr. Jean Fried, who is the co-chair of the International Scientific Committee for this conference. He is also a professor, a project scientist at the University of California, Irvine, and a senior consultant to UNESCO IHP. Jean?
Thank you, Renee, and welcome everybody. For its first online conference, the International Water Resources Association has chosen to combine three most important features affecting water resources: groundwater, climate change, and resilience. Each one has been a subject of passionate discussions, and I hope that their combination in the present conference will contribute to a better understanding of their interactions and the identifications of methods and practices to improve groundwater resilience through the papers to be presented and the discussions. Groundwater is the most significant water resource on Earth, representing about 30% of all fresh water compared to 0.4% of usable surface water. For instance, in the United States, where I live, groundwater represents 90% of all fresh water, although less than 27% of the used fresh water. Yet, legislation and management concerning groundwater are nearly absent, with a lack of scientific and technical knowledge and the out of sight, out of mind nature of groundwater, adding to the complexity of its management. As its use is increasing worldwide, groundwater has to face many threats, among others, those related to climate change, with, for instance, degrading recharge areas due to deforestation and desertification. Climate change is a very hot subject, no joke here, both scientific and political, with many debates on the responsibilities of humans versus nature. Is climate change purely man-made, or is it a purely natural event, or is it the combined result of both mankind's actions and nature? Whatever, we have to consider that groundwater is heavily affected, that we often do not know how to react. Like, for instance, in a different subject, the wildfires, which have affected the Western United States. And that a genuine groundwater policy in every country is critically needed, supported by a solid groundwater governance and implemented through groundwater sustainable management. By the way, it means that surface water and groundwater should be managed as a whole, paying equal attention to both quantity and quality aspects. Such a groundwater policy should be the backbone of groundwater resilience. Resilience is considered as the capacity to resist, absorb, and recover when confronting disturbances and shocks, which depends on governance, economics, quantity and quality, and of course, climate, and is addressed by improving infrastructure, managing demand, reusing wastewater, improving governance to either adapt to the new conditions or to mitigate the effects. Our conference aims at identifying and understanding how climate change affects groundwater, how groundwater reacts to the effects of climate change depending on its resilience, and how groundwater resilience can be improved. And we have chosen 5 themes to support this quest for knowledge: groundwater natural resources assessment under climate change effects on groundwater resilience, pollution and remediation, contribution of technology to groundwater resilience, groundwater governance, management and policy, groundwater education, and capacity building. These themes are the basis of an efficient groundwater policy, answering the effects of climate change, evaluating a groundwater system resilience locally, and identifying what actions have to be done to improve this resilience. Through the examples that you will be presenting, the experience that you will bring to the discussion or in your papers, we hope that this conference will be a milestone in the diffusion of good practices to solve the issues raised by the combination of groundwater, climate change, and resilience. Now, I wish to thank you, participants, to have chosen the International Water Resources Association to express your views and present your experience to help identify the good practices we all need to progress in the sustainable management of groundwater, and also, most important, to give groundwater the place it deserves within the world water resources. I also wish to thank the representatives of UNESCO, IWRA, and IAH for their vision of the future when they decided and agreed to organize this conference. I thank the members of the International Scientific Committee I have the honor of co-chairing with my friend, Professor Ganoulis, for their availability and enthusiasm, and for some of them to have accepted to be session moderators. Finally, but with all my heart, I thank the organizing team for their patience, their availability of every moment, and their competence to solve all the issues of organizing such a wide range conference online and for the first time. Special thanks now to Renée Martin-Nagle, our great master of ceremony. I wish you all a good meeting. Thank you.
Thank you, Jacques. That was a very nice welcome from our co-chair. And I would like now to introduce Dr. Jacques Ganoulis, who is the other co-chair of the International Scientific Committee for this conference. Jacques is Emeritus Professor of Aristotle University of Thessaloniki and a senior consultant also for UNESCO IHP. And I also have to note that these two gentlemen have published more books than I think I have read in my lifetime on water and groundwater. And we are honored to have the two of you as the lead for our International Scientific Committee for this conference. Jacques?
Thank you very much, Renée, for this nice introduction and for pronouncing correctly the name of Thessaloniki. I'm sitting now in Athens, Greece. It is 4:35 local time. I understand that this is a global meeting, online global conference. So I can say good afternoon to Europeans and participants from Africa. Good morning, of course, to Americans, and good evening to people listening from Asia, Japan, Beijing, and Australia. Well, this was a very big bet for the IWRA a year ago to organize such an online conference because of the problem of having the different time zones and how to organize active participation and interaction. Well, here we are now, and I think we made a big step in order to be successful, but we will see the results. So the benefits of organizing such an online conference are multiple. We, of course, can save the carbon footprint by avoiding traveling, the risk of infection from the coronavirus, which is a big deal actually, and of course minimizing the costs. But of course, I think we have to make an effort in order to be interactive and to get some meaningful results and outputs. So it is my pleasure as a co-chair of this International Scientific Committee, together with my colleague and friend, Jan Fried, to introduce you some of the contents of the conference and mainly the main challenges, where this challenge can be seen as a conflict, or I think as a lack of harmonization between man and nature. And I notice here that this relationship is a dialectic one. What does this mean? Dialectic means questionable and not clear enough, because of course, not all the natural laws and behaviors are good for man. We have the natural disasters. We have to be aware about natural pollution, heavy metals. But there are some laws in the nature man has to respect, and man activities most of the time actually doesn't respect these natural laws. So this is a deal, this is a challenge. For example, if you take the natural law of the hydrological cycle, this is a mysterious system of having every year and continuously with a big deal of energy provision, with interaction between the sun and earth, evaporation, precipitation, this runoff and infiltration, which makes the groundwater available. But this, of course, natural water cycle has been modified by human interventions. For example, the climate change. The climate change make a big perturbation to the temperature and the precipitation patterns, but also to the infiltration rate. So this is exactly one of the main challenges we have to afford in this conference, the sustainable or resilient use of groundwater and the climate change as a natural, say, property of the water cycle, and how to harmonize the natural law of water cycle and the use of groundwater. And in our association, we adopted a scientific approach, but I will say another Greek word, an epistemic approach. What is the difference between scientific and epistemic? Epistemic is scientific, of course, but critical. And we want to put forward knowledge which is easy to understand, of course, but also useful to implement in policy, in management, in groundwater governance. So I think during these sessions and during the exchanges, we will be able to have some results about how to increase groundwater resilience under climate change. So in the International Scientific Committee, in order to be able to reach this goal, we divided all the thematology in 5 sections. As Professor Jean-Fried mentioned before, the first one is this interaction between the water quantity, groundwater quantity under climate change and the water cycle. Of course, we need a lot of observations, satellite data from satellites, time series which are not yet available in order to understand better what is the influence of all these climate changes, temperature, precipitation, infiltration, to the groundwater resilience, which means how we can avoid the depletion of aquifers because of the extensive use from agriculture and other activities. So this is a big theme which is fundamental in order to understand the problem. Then we have groundwater quality, of course, groundwater pollution and remediation of aquifers which are polluted. And this is not easy because, as you know, diffuse pollution from agricultural activities, from pesticides, and other activities which are not point-oriented, make a big issue how to clean up this groundwater. And this is together with ecosystem remediation and the theme number 2. Of course, in all these activities, we can think about how to use new technologies, satellite observation, data storage, and how to use computers and software. For example, groundwater simulation and modeling is an important tool in order to understand better this interaction between man activities and the nature. And of course, last but not least, there are 2 items which are interconnected: groundwater governance, which is not exactly policy or management. It's how to put management and policy into the political framework. And political decisions are very important in order to get sound and good governance. But good governance cannot be achieved without education and capacity building. Thanks to UNESCO ISP, we have here the E from UNESCO, which is education, the big E. So we will get a lot of information how to advance in education and capacity building in order to reach a more resilient governance, groundwater governance. So thank you for listening. And I'm sure that during these 2 days, starting from tomorrow, we will have a good interaction in order to make progress in scientific knowledge, but not only, also for the application in policy and good governance. Thank you very much.
And thank you, Jacques, for explaining to all of us the theory behind the 5 themes of this conference. It gives me great pleasure now to introduce our first keynote speaker, Jay Famiglietti. Jay is Executive Director of the Global Institute for Water Security. He's a professor in the School of Environmental and Sustainability at the University of Saskatchewan, and he and his team have done groundbreaking work on using satellite technology through GRACE to monitor differences in groundwater quantity. Jay, I'm looking forward to your presentation, and I'll turn it over to you now.
Good morning, or good afternoon, good evening to whatever time zone, to everyone, whatever time zone you may be joining the conference from. It's really an honor for me to present at this online conference. I thank you very much for the opportunity. I need to give a special shout out to my friend and colleague, Professor Jean Fried, who I haven't seen in probably about a decade. Wish that we could be doing this together in person. Can't wait to see you again. I'd like to share with you this morning an overview of the research that my team has performed really over the last quarter century, primarily using the NASA GRACE mission, Gravity Recovery and Climate Experiment mission. And what that research directly or almost directly implies for groundwater and for humanity. It's really been a bit of a journey. When you start out like we did, we started with my first graduate student to work on this topic was Matt Rodell back when we were at the University of Texas, and I'm still working on it today with my current crop of students and postdocs and research scientists at University of Saskatchewan. When you start out working on a mission like this, before it even launched, we started in 1996, 1997, and it didn't launch until 2002. You don't really know the path that it's going to lead you on. And we did not set out to identify groundwater depletion. Really, we started out instead to determine what sort of information that we could gather about hydrology from the GRACE mission, and whether or not it matched observations. And we were thinking a lot about how we could use it in our predictive models, and especially in the land surface models that we use in climate models. And while we ended up doing a tremendous amount of that, this picture that the GRACE mission revealed, and that's what you're looking at in the cover slide, I'll be explaining that, in my opinion, is one of the most compelling global images to emerge from satellite hydrology. It directly maps and quantifies the shifting patterns of global freshwater availability, the rates at which those patterns are changing, and it points directly to humans as the cause. And it underscores that we have a full-on global groundwater crisis. And what I'm talking about today doesn't even include all the groundwater quality issues. So this map and this work that we've done, I think really helps crystallize many of the consequences that we all know and talk about. We've already started to hear about today, including the clear threats to water and therefore food security, transboundary water issues, issues of equity and accessibility, the potential for conflict, sea level rise, and so on. What the GRACE mission can't tell us, however, is what to do about it. And that part is really up to us, and is in large part what we'll be talking about at the conference today. Could I have the next slide, please? So here's the GRACE mission. It launched in 2002. It ran until 2017. Most of the work that I'll present today is based on these data. The GRACE follow-on mission, or GRACE FO mission, launched in 2018. It's almost exactly the same configuration, which delivers data at the same space-time resolution as the original GRACE mission. In the NASA language, it's called the Climate Continuation Mission. The follow-on is called the Continuation Mission. The argument being, and some of these arguments are actually groundwater arguments, that the data are so important that the mission should run nearly continuously. GRACE is unusual for a satellite in that it functions more like a scale than, say, an optical satellite, which is effectively taking pictures, or a satellite that senses temperatures or other emissions from the surface. GRACE is literally weighing the water storage changes over land by tracking their gravitational tug on these two satellites that you see in this image, and the resulting changes in their orbit. So the different patterns of water, more water, less water, exert more of a gravitational tug on this satellite, spread them out a little bit more, move them up and down a little bit. We can track their position extremely accurately at the submicron level. A micron is a thousandth of a millimeter, so that we can map out the regions of the world that are gaining or losing water mass on a monthly basis. Some other issues to keep in mind when you look at some of these slides: GRACE measures the change, not the absolute amount, in total water storage. So all of the snow, all of the surface water, all of the soil moisture, all of the groundwater together. If we want to separate out the groundwater, we have to come up with supplementary data. It works at large scales in space and time, monthly and longer time scales. In fact, that map that I'll return to a few times is actually a long-term map. It represents many years and shows trends over long periods of time. But we can also look at monthly ups and downs, and we'll look at some of those data. And for large regions, 150,000 square kilometers and greater. So we're not talking about weather prediction here. I'm in Saskatoon. We're not talking about monitoring the soil moisture that's happening here on the campus of University of Saskatchewan on a daily basis. We're more looking at changes that are happening, say, at the scale of the Saskatchewan River Basin, which is greater than 150,000 square kilometers. And the accuracy is 1.5 centimeters, equivalent water height. To think of what that means, it's about 1.5 centimeters of water spread over this 150,000 square kilometer region. So the change has to be bigger than that to perturb the satellites, to significantly perturb the satellites. Next slide, please. This is just a quick slide to show the GRACE follow-on launch that happened in May 2018. It was great to be there. To me, it represented the opportunities for the next generation. I and my team had worked, had this mission sit in the real sweet spot of my career. It started when I was an assistant professor, and by the time it wrapped up, I was up here in Saskatoon. I trained many students, and I kind of feel like the GRACE follow-on is for them, the next generation, and to take and improve upon some of the things that that we identified in the first mission. And those data are now the data from the follow-on mission are now available, and I'll show some of those towards the end of my talk. Next slide, please. Well, so here's what the GRACE mission showed us. It allowed us to produce this first of its kind trend map that shows these trends in the changes in the total water storage over the lifetime of the mission. The blue colors in the background represent those areas that gained water mass during this time period, and the red colors represent those that have lost water mass. There's a broad background pattern of the light blues at high and low latitudes, or across the boreal regions and across the tropics. And in between, we see there's a background pattern of red in the mid latitudes. And then there's the darker hotspots that are sprinkled across the top of the map. Can I ask you to advance a little bit? We're going to work through this slide and start to talk about some of these hotspots. So some of the bigger hotspots for water storage change, of course, starting with the ice sheets. Greenland and Antarctica are melting away and driving sea level rise up at a rate of about 3 millimeters per year. Advance, please. Yes, thank you. Alaskan glaciers, the Patagonian glaciers, glaciers in Colombia and Peru. And some of these background, wow, someone's doing a great job anticipating my next moves. Thank you very much. This is the background pattern that I'm talking about, which is really a climate change driven pattern. The high latitude and low latitude precipitation increases, and the mid latitude drying that we'll refer to. These are some of the hot spots for interannual variations. We hear about the changing extremes and how, or that they will be changing and strengthening, and we're starting to see that appear in our data with drought and flooding around the world. Next, please. And so here's the focus of our meeting, groundwater. These spots show the hot spots for some of the largest amounts of groundwater depletion around the world. It is, as we know, many of these regions are unmanaged. They contribute greatly to our food supply. Next slide, please. So we'll be returning to this over and over again. If you take those groundwater hotspots and you map them to the YMAP template of aquifers, you get a map that looks like this. And so of the 37 YMAP aquifers, we see that over half, something like 20 of them are being depleted, some of them quite significantly. Next slide, please. These are some of the time series that go along with some of those aquifers that are under great stress. Next, please. So a lot of that was summarized in a paper that I called the Global Groundwater Crisis. And when I wrote that paper, I wasn't even thinking about, I was not connected to the governance community, the policy community. That's, for example, why Jean-Fried and I never did any work together at UC Irvine. I wasn't thinking about this at that time. The data hadn't spoken to me yet. I was still trying to figure out what I was seeing. And once, I see what this community already knows, but put together this global picture, it's incredibly compelling, and we need to work together on it. Next slide, please. There is a climate change theme to this online conference, and there is an awful lot of climate change in this data. Advance, please. So the IPCC tells us to expect that the wet areas of the world are getting wetter. Next. That the dry areas of the world are getting drier. Next. So this is an IPCC chart from the fourth assessment report that shows that the precipitation changes we can expect by the end of the 21st century. So that same pattern of the high latitudes and low latitudes getting wetter and the mid latitudes getting drier. Next, please. Next. So I, for a long time, would ask the question, when the data first started emerging, we were wondering, is this happening? Are we seeing it? Are we seeing it? And it's pretty clear that we're seeing it. And next, please. And one more click, please. And one more click. Thank you. So we are seeing that when we split up the data, like you see, like I just showed in the slide that's now underneath this graphic, we are seeing that the dry areas of the world are getting drier, and that's after we pulled out all the aquifers. So this is just the background color, and the wet areas are getting wetter. So this was something that was predicted by the end of the 21st century, and we're seeing it now. Next slide, please. So that doesn't bode well. The dry areas of the world part, getting drier, doesn't bode well for all of these aquifers because, next, advance please. They're all in the dry areas of the world. That's why we use them. They underlie our great food producing regions. We're digging more and more wells in there while they continue to dry out. So this incredible positive feedback that's happening that I expect will lead to an acceleration in the drying that we see. Next slide, please. Okay, so the first GRACE mission showed us, so this ended in 2017, that the human fingerprint on the freshwater landscape through climate change, through melting ice, like the ice sheets and the glaciers, through the changing extremes, the hotspots for flooding and drought, and for groundwater depletion is a dominant force, the dominant force that is dramatically changing patterns of freshwater availability. The change and with it, the major threats to water security and to food security. Again, these aquifers are providing 40% of the water that we use for irrigation. So without that groundwater, water security, we will not have food security. And I think it's pretty clear that it's happening much more rapidly than most people realize. So, you know, it's on us to communicate this. And I hope that graphics like this do help. You know, we keep using this term, making the invisible visible. And I hope that graphics like this help to do that. Next slide, please. So that's what the GRACE mission showed us. What the GRACE follow-on mission is showing us next is that things are not really improving. So I put in here some graphics from a few of the papers that we've written, and my colleagues have written many more, but these were some of the first ones that we wrote. We kind of go hotspot by hotspot and convince ourselves or try to understand what we were looking at, and then we realize, oh my gosh, it's groundwater. Then after you read a few of these papers, you look at the map and you realize, okay, there's a lot of groundwater depletion going on, not only in these spots, but right in all across the world, in China, you know, on every continent. So I wanted to point out that we wrote this in the upper left. Our first big paper that we wrote on groundwater depletion was one that Martin-Nagle took the lead on, and that paper was published in 2009. And if you look, you see that you know, that groundwater depletion is continuing up until today. Next, please. So the California paper we wrote in 2013, and we focused on this period from about 2006 to 2010, big drought period. You see that we continue to sort of step down in California. Next. Middle East, same deal, right? And if we look to the right of that arrow, we published that paper in 2013. Same thing for Colorado River Basin. These trends are largely linear. They're continuing. They're not going to change unless we intervene. Next, please. And I should point out that not only are the trends within the hotspots changing, but the global maps are not really changing. Okay, so the GRACE-based map that I showed you of the aquifers, you know, those trends are linear, they're continuing. So the cumulative amount of disappearance is increasing, the trends are roughly the same. So Sasha Ritchie's paper and Matt Rodell's paper in 2015 and 2018 largely look the same today. Next, please. So let's talk about some of the implications that, you know, it's not all of the implications, just some that I think are made very clear by the GRACE mission, looking at 20 years of these data now. Food producing regions are in what I call a state of chronic water scarcity. Those hotspots for groundwater depletion underlie the world's great food producing regions. Again, they provide about 40% of the water for irrigation water supply. Those red hotspots show us that, again, not only is regional and global water security at risk, but so too is food security. The groundwater that fuels food security and therefore human security, as we all know, is largely unmanaged and is at great risk of continued degradation and depletion. There are distinct classes of water haves and have-nots. I've shown you that the dry areas of the world are getting drier, that the wet areas are getting wetter, and we know that climate change is running full speed ahead. I've shown you that those hotspots where more and more wells are running dry, and ironically, more and more wells of all depths are being drilled, right? So there's really a serious positive feedback that's accelerating drying. Of course, we have issues of equitable access and environmental racism to contend with. And we should be prepared for water-driven climate migration if we don't get that groundwater sustainability under control. Hydrogeological exploration of the world's major aquifers. GRACE can help us understand the rates at which groundwater is disappearing from these regional aquifers, but it can't tell us how much is left. It can't tell us how its quality changes with depth. Can't tell us what practices on the ground are putting all of these at risk. It's really up to us to do the measuring, the monitoring, the reporting of groundwater quantity and quality data, and sharing those data across political boundaries. By the way, all of this certainly would have been done, certainly the exploration would have been done if these were oil reservoirs. I think we need to recognize that groundwater is a critical element of national and international water supplies. Those big red groundwater hotspots are showing us exactly where we're losing our water from. Groundwater needs just as much protection and discussion and negotiation as our rivers, whether we're talking about intra-national within countries. And here I'm thinking about the fact that we don't really include in the United States groundwater in discussions of the Colorado River Basin. It's all about the river. So intra-national and international. And unfortunately, almost always, that's just not the case. It really needs to be, or we will be forfeiting the resilience of our future generations. And regional groundwater problems require regional solutions. Again, that map shows us that those large aquifer systems span political boundaries. And that implies that the solution should as well. And so, as we've already heard, that includes equitable and inclusive governance, that includes water diplomacy, that includes capacity building, and much more. Last slide, please. I'm not going to wrap up with a list of items that we need to accomplish on the technology, policy, capacity building, governance, data sharing, although I think that's not a bad starting list. Others have already done a better job and will continue to do a better job. But there is an urgent need for best available groundwater science and engineering, and for management and for policy innovations. It may well be time for global groundwater sustainability targets like we have for those for climate through the IPCC. It's certainly time for greater representation of groundwater in the SDGs, especially SDG 6. But I and my colleagues need to be able to, in academics, need to be able to work with you in these transdisciplinary teams so that we can provide the underpinning science to support the discussions of adaptation strategies and science and policy needs. And I think the key, when I think about an important limitation, I think a key missing link that provides the momentum for our involvement in activities like, next, please, the Global Groundwater Statement from the Chapman Conference in Valencia last year, next, and click one more time, or the Groundwater Governance documents, which lay out a fantastic framework, next please, is that we need to have higher level recognition of these things so that we can get some momentum on these activities. We need international funding opportunities. We all often have national funding opportunities, but not international funding opportunities that allow us to put together international teams, like the recent Belmont Forum call that was out for groundwater sustainability, and an international collaboration call that came out in Canada. So my message to the group is that without that higher level of recognition within the SDGs and the UN FCCC, not only will it be difficult for us to achieve our large-scale groundwater sustainability and resilience goals that we all have, but it would be really difficult for us to convince our home countries to invest significant resources in large-scale groundwater activities, which means that it'll be really, really difficult for us to train and build the workforce that we need to build at the scale, right, that is consistent with the scale of this problem. So I'll stop there, and I apologize for going over in time. Thank you very much.
Thank you, Jay, so much for your presentation. You and your team, as I said, are doing critical work, and good policies can't be written without good science and data to support them. And you are certainly doing your part to provide data on groundwater. And thank you also for the call to action, because we all know that groundwater is the hidden resource, and it shouldn't be hidden because, you know, we see it when it's brought to the surface, especially for food and irrigation. Now it's my great pleasure to introduce my friend, Karen Villeroth, who will be the second keynote speaker this morning. She is the principal researcher and coordinator for groundwater for the International Water Management Institute. And she's also the coordinator of GRIP, which is the Groundwater Solutions Initiative for Policy and Practice. And Karen, the title of your presentation, Groundwater in a Changing World, Buffer or Burnout, is very intriguing. And so I look forward to hearing you.
Thank you very much, Renee. Thank you for the chance to be part of this conference and for inviting me. And thanks to the organizers for this great opportunity. Yeah, so I will jump straight into this presentation. I think actually Jay covered very well the topic of buffer or burnout, where we are in a way globally today. And my presentation will actually hinge a little more around some of the results that we have come up with over the last years in terms of understanding impacts of climate change on groundwater, and then some of the opportunities for building resilience. Next slide, please. So in that, I will jump straight to number 2, and that's going to be on this, I call it the quadrant of climate change. Impacts on groundwater, and I'll explain what that is, but it's basically looking at direct and indirect impacts, and then both on water quantity and quality, and then some aspects of adaptation and ways forward. Next slide, please. So just for a little bit of an introduction, I like to put this out because it kind of puts groundwater in perspective, right? We have some surface water there, and then we have this huge body of water underneath that we don't see, and we still use it quite a bit. But even the use of it is sometimes invisible, you know, because it's from few wells here and there, and it's not being necessarily monitored and tracked. So this is kind of what we're looking at, and I think with all of the drivers of change, groundwater will become more visible, and people will start seeing this as very critical. Next slide. Yeah, so here are some of the drivers. I think you all know them. We have climate change, we have urbanization, human population growth, we have extinction of species, we have deforestation and desertification, and many factors leading to more stress basically on our planet. And you can say that groundwater depletion is actually one that doesn't figure in this figure, and maybe we need to put it in there. And of course also COVID-19, I didn't put that in there, but I guess that's like overriding everything at this particular point in time and making everything more difficult. Next slide. You can go to the next again, so we can see the full picture here. So basically showing how little groundwater we are using in terms of what's available. So you can see the blue is the total fresh groundwater available in globally. It's about 22.6 million cubic kilometers globally, and we're only using about 1,000, maybe 1,500 today. And then you can see the renewability is about 10 times as what we're using. So we're not near to our sustainability limits. The problem is that the distribution. I think what Jay showed was very much underlining that whole problem area. And where groundwater is still available, it's not really required so much, but it may very well be in the future. Next slide. This is showing freshwater availability or water stress, if you like, if you're talking in SDG terms. This is from 2004, so it's a bit old, but it still remains valid. And you can see all the areas there on the north of Africa, they're all with high water stress. But if you click the next one, you can see that underneath a lot of these areas, we have huge storages of groundwater. And this doesn't come out. Again, groundwater is invisible, but what people are using basically in those regions are indeed groundwater, and they are heavily dependent on it. And the other side of the coin is that this is fossil groundwater, unrenewable groundwater, and it won't be replenished in our lifetime. On the other hand, this has been, you can say, put down under earth millions of years back in previous historic times when the climates were different. It also tells you how important climate is for groundwater. Groundwater is a memory of climate, you can say. Next slide. The trends in groundwater use, the bottom one there, it's about, you can see, you have to see to the left, that's a scale for groundwater between 1,000 to 1,500 cubic kilometers per year. And it's about 1/3 or something like that in terms of what is being pumped totally today in terms of fresh water. Next slide. And you can see the increase from the 1960s. That's when groundwater and basically water abstraction really took off. I think I will skip this, but just saying that groundwater has so many inherent good properties, and that's why it's so critical for humanity. It's available in many places. The quality is good, it's protected, and we have the technology to access it, and there's much increasing demand for it. Next slide. Some overarching question or sort of knowledge points about climate change and groundwater. We already know that it's a buffer, as we put forward, but only if it's well managed. And this is where the whole crux of the matter is. It's not a buffer if it's not well managed. In arid areas, groundwater recharge will increasingly become episodic and focused. I will show some results from our research. And then the most vulnerable areas, large coastal cities, tropical deltas, small islands, because of seawater intrusion, subsidence, and dense populations. So we have different contexts where groundwater is playing different roles and different issues will arise. In Denmark, you can see to the right, the lower picture there, that's what it looks like under climate change here. We have lots of groundwater and it's coming to the surface. Also increasingly, we will see groundwater depletion coinciding with flooding. And so you have flooding on the surface of the ground, but you have 100 meters down to your groundwater. That's a new concept we have to get used to. Next slide. We don't know the exact impacts, and that's what we're looking at in this conference. It's a very timely conference and picking up from previous conferences. So this is really great. There's impacts on quality and quality. I'll come back to that. And as I said before, groundwater is sort of the memory of climate. And so understanding the historical aspects of groundwater recharge and storage and then how it has built up till today is very critical. And then I think also what Jay said is that we have human impacts and we have climate impacts. And sometimes they're not easy to distinguish. Though I think we know that where we have a lot of irrigation happening, it's a lot to do with human abstractions. Next slide. So here's a quadrant that I was mentioning earlier. So we have water quantity on one axis and then and quality, and then we have direct, indirect. I'll give a few examples of each and give more prominence to the water quality, because I think the quantity aspects are to some extent quite well known, and especially the indirect aspects are also not very well known. So I'll focus on those. Next slide. So next again, water quantity. I already mentioned that we did some work on looking at these episodic events where we see that groundwater is basically being replenished. And this is in arid and semi-arid areas. Here we're looking at the focus area, the continent of Africa. And here you already have a lot of different climatic zones. And what it tells us is that when you're in arid areas, these areas might be less vulnerable to climate change, because if you do have huge rainfall events, maybe with a time interval of 10 years, you can still save your groundwater because you will have disproportionately more recharge during those periods. But of course, it's very critical what happens in between and if your storage is great enough. And I think those are some of the points that we still need to grapple with to come up with better resilience by having better predictions and seasonal forecasts, etc. Next slide. Also from the same team, together with Richard Taylor and other people that I shouldn't mention one name and not mention others, but a lot of people have been involved in this work, and it relates to the differences across the continent in Africa. You can see you have a blue and a brown, and at the same time, concurrently, you have a very dry situation in the southern part and a very wet context to the north. And this was during a strong El Nino event, and this was supported by actual data of groundwater level changes. And so you can see it's not only over time that you see changes, you see it also geographically and with different specific climatic events. Next slide. We go to the indirect water quantity aspects. And I just show one graph, next one, where we can see that, and it's not rocket science, but basically some results from British Scanlon and team showing that when you have dry periods, the pumping goes up. You can see that where you have the dry white spots there, you have groundwater pumping going up. That's not rocket science, and that's what we'll be seeing. And it's an indirect impact, because when you have dry climate, the humans start using more groundwater. Next slide. Then we go to the water quality and the direct ones. Yes, this is work ongoing at the moment and about to be published from Botswana, where we look at water quality in a smaller catchment as a result of flooding. And what was found there was that both groundwater and surface water were heavily impacted by the flooding in terms of pollution. And groundwater was a little slower in reacting. Surface water was quicker, but I think that's maybe not so hard to understand. What I think was also quite clear and has been identified in developed countries as well, that land use is very important. So where you have irrigation, agriculture, and where you have waste deposits, that's where you see the most impacts of the groundwater quality. I think I'll go a little quickly, not to lose time. Next slide. Next, yeah, so to the indirect, I have a couple of examples here. This is actually from the same area that the previous work was done in Botswana, actually at the border between South Africa and Botswana, where there's a transboundary dolomite aquifer. And here there's a well field which has been encroached on by a village. And you can see that there's pit latrines right next to boreholes. And just before the big flood event that I was talking about before, there was a period of 2 or 3 years of drought in that same area. Next slide. This is a little busy slide, but if you look at the right side, you can see Botswana and South Africa and the borderline between them, and the village there in the red circle. And that's where we have this case happening. We have water supply from groundwater in this area, and it's being supplemented also with surface water from the Gaborone Dam. Now, when the drought set in, there was a restriction in water supply. Next, you can see there's a cutoff there. So you can see the dry and the wet. Next, because of the cutoff of water supply from the wells, people starting using their pit latrines rather than using their flush toilets. And this aquifer, the Ramotswa dolomite, is already contaminated by nitrate. And so because of this use of open defecation or pit latrines rather than using flush toilets, meant that the groundwater was contaminated higher as a result of this, or at least the waste load was higher. And then possibly during the next flooding, you'll get a big flush of contaminants going through the system. So this is one example of indirect impacts of climate change on groundwater quality. Next slide. So my last case is food trade, looking at arsenic, how it's being traded in food crops that are contaminated from groundwater irrigation. This is work that's been going on very recently. We hope to publish it quite soon. So what we did was to look at where we have hazard areas in terms of high arsenic in groundwater. We looked at irrigated areas from groundwater, and we looked at where we have the various production zones of different crops. Rice is the most critical one, so I focus on that right here. Next slide. So what we found was that about 4.7 million megatons per year is contaminated and traded globally, which is about 10% of the global rice trade. And that trade happens from the major producing areas. So it's from India, Bangladesh, partly USA, Thailand, and so on. And you can see here some of the countries here that are listed and who are the recipient countries. An interesting aspect was also that many small countries that don't produce any rice at all import a lot of rice, and that's a major source of arsenic because they don't drink any contaminated water like in Bangladesh and India. So that's the sole source, and import can be a quite significant source in that case. Next slide. Groundwater has a big role to play also in terms of resilience, and this is what we call groundwater natural-based infrastructure. And here's a couple of examples. I think we all know about managed aquifer recharge, and here there's some examples of derivatives of that. For instance, riverbank filtration, payment for ecosystem services for MAR, using wastewater for MAR, and also using underground transfer of floods through managed aquifer recharge. We also include what we call bioremediation through groundwater as a groundwater-based natural infrastructure solution. So everything that has some component of groundwater in it to enhance resilience, to enhance water security and environmental services. That is what we call groundwater-based natural infrastructure. Next slide. I think I'm about to run out of time. So here's an example from Paul Pavelish and team. I think he'll be presenting later in the conference, so I hope you will have a chance to hear more details about it. This is an actual case from implementing this underground transfer of floods in India, where the infiltration or the recharge is concentrated and enhanced in these ponds during flooding seasons, where flood water is diverted to these ponds. And there's a lot of lessons learned from this that we need to take into account when transferring and upscaling these kind of solutions. There's a lot of rich information here that we need to look into, but I will not give too much away and leave this to Paul and ask you to come back to see the rest of this story. Next slide. Just looking at MAR in general to say that it's not a panacea. I just looked at Jaipur because there were some data there. And if we look at the recharge that is there and we assume that we stopped our pumping, it would take 86 years to regenerate the lost storage based on a natural recharge. And if we look at it at the global scale, or at the Indian scale, and use average numbers, it would take about 10 years to recover groundwater depletion in India on average. Of course, there will be high inhomogeneity across the areas. Next slide. Yeah, so next possible ways forward. I also believe that we really need to build the capacity. We need to build the knowledge, we need to build the partnerships so that groundwater becomes more visible, it becomes more known, it becomes more in demand in terms of management and governance. And what we're doing in the GRIP network is to develop tools and approaches and products for that. And this is one of them. So groundwater, it's giving a timeline of how groundwater has been developed from early human development up till today. And you can see the steep, almost exponential development over the last generation. Next slide, or next. And we also translated into Burmese because there was an demand for it there and interest, and we can translate this into any language if you like, and help other countries to also get the idea of what groundwater is and the significance of protecting and managing it correctly. Yeah, so we start with a lot of straws in the groundwater, and we have also some water that's not very well tasty. And we want to move to this water food energy nexus, where we're looking at the linkage between groundwater and energy, for instance. There's very strong linkages there in terms of management and so on. I think Aditi and others will probably talk about that later today or later in the conference. But I also want to emphasize our own footprints in terms of what we eat and what we consume, because it has a lot to do with how we can manage demand for groundwater at the end of the day. So I have almost become vegan, and I think that's what more people should do. Next slide. So we should teach our children about groundwater from early age so that they appreciate it and also take it forward in their professional careers. And yeah, next slide, last slide. We just have to hope that they take it up and find groundwater as a compelling career in the future. And of course, the partnerships, the GRIP partnership, and the statement that Jay was mentioning, I'm also part of that. I'm also part of John Cherry's groundwater project. So I think we have so many great initiatives happening today. We all have to take advantage of it and partner around it and get the best out of it. And really, because of the 22 roadmap that we have already set up now to get groundwater on the global map, we are all working around it. And it's great to be part of that and to work with all of you on these aspects. So I think I will stop with that. Thank you very much.
Thank you, Karen. That was just a fascinating presentation. Not only was it content rich with lots of data, but your images and graphics are gorgeous. I don't know who does them, but they express so much with just a single slide. And I think that having you and Jay as our keynoters for the opening session was a perfect idea, because Jay provides data from the sky and you provide data on the ground. And together, maybe the two of you and your colleagues can get the information through to the policymakers, but gathering the data is so important. Now we've allotted some time for questions and answers, and I'm going to turn the floor over to Dr. Mary Trudeau, who is a lecturer at the University of Ottawa. She's been involved with water and groundwater for many years, and so she's quite knowledgeable, and she's also helping IWRA in a number of ways too. So Mary, are you ready?
Yes, thank you, Renee. And it's actually very good segue into the some of the questions that have come in, which do pertain to data. So for both Jay and Karen, and one of the questions is more specific with respect to GRACE, and can GRACE be used at local scales? And can it be used to identify depletion or overexploitation of reservoirs? And if so, at what scale?
So no, it can't be used at local scale. The minimum scale is about 150,000 square kilometers in space and about a monthly time scales in time. So it's actually a pretty coarse resolution. If we wanted to use it at higher resolution, we'd have to do some kind of downscaling, perhaps physically based with a model. People have been doing statistical downscaling. And I think there was a second question about overexploitation, and certainly we're seeing that at large scale. I talked a lot about that.
Right. Okay, so maybe Karen and Jay, if you have the information, you could comment on sources of data for local communities. If people in our audience are working at a more local scale, where would you suggest they go to find data sources on groundwater?
I can come in here, Karen, if you like. Generally speaking, there's a lack of data on groundwater at the local scale. Were you mentioning only quality or quantity, or both?
Both.
Both, okay, yeah. So especially for quality, it's very limited. For quantity, there might be data collected through the governments or the various authorities. There might also be some organizations that are supporting some of these things, like for instance through citizen science. That is increasingly coming up now, and groundwater is becoming sort of a part of citizen science, because at the end of the day, measuring a groundwater level is not that advanced. Quality is, of course, a bit more advanced, and I think that's quite early phases still. But generally speaking, there's relatively little known. There might be, of course, in certain areas where there's a well-known problem, like with arsenic and so on. There's, of course, more focus on identifying where the issues are, and for instance, like labeling wells according to whether they are at a risk for consumption or what. And other aspects could be like salinity. People can taste it themselves, if there's a salt problem. But otherwise, many water quality aspects cannot even be sensed, through just normal human senses. So you need to have a kind of a monitoring system in place. Thanks.
Can I throw something in? There are other remote techniques from satellites that can be used that have their own limitations, but have greater resolution. In Niger, we're using radar for shallow groundwater, but it covers a large area. and you can get much better resolution. So there are other techniques out there, but GRACE certainly is an important tool.
Great, thank you. And any other panelists? I know that local well records seem to be the go-to data source at a local scale. And those are often not stored or recorded easily, so it can be very time consuming to access available data records on a local scale. So we also have a question related to the arsenic contamination. And Karen, maybe you can just give some information on whether the arsenic contamination is related to depletion or natural sources, and just a little bit more information on the relationship between groundwater depletion and arsenic contamination.
Thank you for that question. I must admit I'm not an expert in that particular aspect of it. I haven't researched in depth, so I don't want to be put on the spot in a sense, but I know there are issues related to, for instance, the chemical oxidation levels in groundwater that can affect, you know, the release and the balance between dissolved and absorbed or complex or whatever arsenic. And so when you draw down your groundwater table, you can have some processes happening, but I don't want to go into details on that. Thanks.
Okay, thank you. So we have a number of questions on the GRACE satellite data and the technology. Maybe we can start with a few questions about maybe a bit of a challenge where one participant is saying that there's no evidence of depletion of the Guarani aquifer in Brazil. And so the question is, you know, what is the validation on the ground, you know, earthbound measurements to validate the results that are coming from GRACE?
So every time we write a paper on a particular hotspot, we try to assemble the available, the data that are available. And as we just heard, it can be kind of challenging. So it's we do the best we can, and the most places that we look, it's, you know, it's never going to be perfect, but the trends that we get out match the trends that we see on the ground. The Horny aquifer, you know, that's not my understanding. My understanding is that it's under threat, and that it is one of the few places where actually there was some hope, at least at one point, of getting an international agreement in place. And I haven't followed that, but a few years ago, it seemed like it was moving forward. But I think, you know, it also gets to the challenge of what you might see locally versus the larger scale picture that you see from GRACE. So certainly, you know, any place that we focus in on, I lived in California for 18 years. And, you know, you could say the same thing about where I lived in California. There's really no evidence of, at certain times, right? In certain regions, you know, you might not see evidence of this larger scale wetting or drying, but when you take that much broader view over the longer time period, you know, that's what's happening. So I would say this, that I don't think there's ever been a place that we have looked where the data don't match, that GRACE doesn't agree with what we see on the ground. It's not perfect, but at the right scale, at the right space, the monthly and longer time scales, and 150,000 square kilometers and greater, then the agreement is generally good.
Okay, great, thank you. And there's also interest specifically in Greenland, and the indication that seems to be that it's losing stored water, presumably ice, but that the center may be increasing. And if that's correct, could you maybe talk a bit about those results?
Yeah, I think that that's exactly what's happening in Greenland, is that there's accumulation in the middle, but it's melting along the edges, and it's melting quite rapidly. And so that's also been verified, not necessarily by the GRACE data, but by higher resolution radar data like Dave Kreamer just mentioned. So a lot of ice work is done with radar as well. So yeah, that's what's happening. There actually is accumulation in the middle, but tremendous amount of melting on the edges. And so the net is this, I forgot what it is, separately between Greenland and Antarctica, but together they're pushing up sea level rise. Sea level is rising about 1.5, 3 millimeters per year. About half of that is from mass increase. The other half is from thermal expansion.
Okay, thank you. And another question for Karen, maybe you could talk broadly about some of the trade-offs with, the managed aquifer recharge. For example, does the stored water create more opportunity for mosquitoes? And are there other sort of social or, environmental implications of that technique?
Thank you for that question, Mary. I think it's very relevant to bring it to the fore. So the managed aquifer recharge approach is coming very much forward, and we've actually published a book, or it's coming out very shortly, together with UNESCO and IAH, where we are scrutinizing and portraying, I think it's 28 cases around the world about these different MAR schemes and bringing in the actual people involved. So we have them as authors to the different cases and get the insights and so on. And I think there's a rich material there that we can look into in terms of, both the breadth and the width and the impacts and the performance and the costs and so on of these technologies. This was our objective of this book. And I think there's some very interesting things that come out. I think generally speaking, MAR has a lot of potential in terms of supporting resilience and the water security in specific areas. I can say that MAR is actually implemented across the globe with different technologies, with different purposes and objectives, and so on. But they do show good impact in many cases. There are still, of course, challenges. I think we have to keep that in mind and also be aware of it as we go forward with these technologies. And those were some of the ones that you were discussing. So, for instance, the mosquito thing, I don't think it's a major issue. Of course, if you're using what they call infiltration methods, like what was the case that I showed here, then you could have local issues of mosquito breeding, which could be a problem. I haven't heard about it actually, but other times you used to inject water through wells, and there you don't have open surfaces, so then it does become a problem. In terms of more social and economic issues, I think it's important that you have your local stakeholders involved, especially in the developing countries, and you also have the women involved, because they are often the main stakeholders in terms of supplying water and so on. So they have to be capacitated and be part of the management kind of team around these schemes. It's also very important to keep track of water quality. This is more of a technical issue, but I think it's an overarching lesson that has been learned across most of these cases, that we need to understand what happens when you put water underground. Does it create any issues in terms of poor water quality that's injected and then becomes introduced into your groundwater, or does it create internal inherent issues when the water quality and the water coming in is different from the inherent water quality? That can also happen, and especially like with arsenic that I discussed earlier, which is a separate topic of arsenic, but nevertheless a very important one. So I think that's something that's important. We also need to look at the water quantity, whether we actually have the water needed to put underground when we want to implement these schemes. Thanks.
Thank you. So we also have a question back to Grace, trying to, I guess, really understand the data and how it works. So is extracted data from unconfined or confined aquifers, groundwater, and how can you tell whether the anomaly is due to ice melt or groundwater and snowy catchments?
So the GRACE data really just give us a mass change. So it'd be like if you were weighing yourself every day, or taking a monthly average or something, you might see that this month you gained a pound, and next month you gained a pound, and then the next month you lost 3 pounds, and you start to see the seasonal ups and downs that may have something to do with your diet or your exercise. But my point is that the scale can't tell us where on our bodies that weight is coming from. We need other measurements. So that's what's happening with GRACE. So all it tells us is the mass change. It doesn't, most of it's water. We know most of it's water because we've compared to the different mass changes that happen in regions. But then the challenge is really up to us to put together the data sets to understand where, in that space that you're looking at, it might be a state or a province, it might be a watershed, it might be a big aquifer system. It's up to us to pull together the data sets to understand, the storage changes, what's happening with snow, surface water, soil, moisture, groundwater, within the groundwater, what's happening, is it unconfined, is it confined? So GRACE, it doesn't have that kind of information. It just gives us that overall mass constraint. So that's where all the research lies, is in figuring out how to disaggregate it both in space and vertically, now horizontally as we think about going to higher resolution, and also in time.
Thank you. And David, did you want to add to that?
Yeah, I think one of the important things that the GRACE data does show is that the dryland areas of the world are particularly at risk. I live in a desert that gets about 100 millimeters of rain a year. We've gone about 190 days without measurable rainfall. And in these areas, very often, groundwater is super important, but also for living communities, springs are very important. And slight changes in groundwater tables can dry up springs entirely, and the ecosystems that they represent, they sustain. And so it's a very, very vulnerable position that people in humid climates sometimes don't realize that entire ecosystems and entire ways of life of desert people can be very, very much upset by these slight changes in the dry areas. So I think that that's an important thing that the GRACE data and Jay's work has shown.
Thanks, Dave. So I just want to follow up on that, if that's okay, Mary.
Sure. Yeah.
So I think one of the things that people don't recognize, so you made two excellent points. One is that people in humid climates have a difficult time appreciating what's happening in the dry parts of the world. And I don't have to look past my own family to understand that dynamic, right? My family lives on the East Coast of the United States, and my brother does not understand why we have water problems. And, he says, I look outside and I see rain and I see rivers and everything's great. The other thing is the sustainability. What starts to it's concerned me for a long time, but maybe over the past couple of years is really understanding the sustainability of our desert cities. Now I'm thinking about Phoenix, right? And so what's happening in Phoenix is, continued growth. As temperature increases, the city's becoming unlivable. They do have an understanding of how much groundwater they have, but they're not really looking at, so there's this sort of like, okay, if you want to build a new business in Phoenix, you have to show that there's a 100-year water supply. Okay, great. That's fantastic. But it turns out that, they think they only have about a 300-year water supply. So there's this sort of like disconnect of like, okay, well, maybe Phoenix won't even exist. And, decisions we're making now impact the actual existence of some of our desert cities. And while we may think it's a couple of 100 years away, the more wells we poke in the ground, which is happening in Phoenix and happening in Arizona now because of the drought contingency plan in the Colorado River Basin, then that time scale to the the groundwater apocalypse is shortened. So thank you for bringing that up. That resilience is really critical, especially in our dry lands.
Great, thank you. So we have a couple of minutes left. We have a few questions around governance. So they're not necessarily simple, but questions about the role of local versus national grassroots movement. So Jay, in your presentation, you mentioned the need for national scale action and transboundary issues, but maybe both you and Karen can comment on what you see as, I guess, the most critical governance issues at local and national and transnational scales.
Karen, please go ahead. I think you're on mute.
You're muted, Karen.
Catching that. Thanks for the question. The governance aspect of groundwater is really complex and intriguing, and we're still grappling with it. I think there's still a lot we have to do, and getting groundwater to be visible, to be monitored, to be well known, to be understood, I think is the first key, basically, and I think we all agree on that, and that's why we're here. Because if we don't have any basis for making our decisions, for discussing how to share it and to look at impacts and so on, we're basically walking in the dark. So I think that's the first thing. And everybody has to be informed. So it has to be not only the academics and the professionals. It has to also be the citizens and policymakers. Sometimes policymakers also don't know about groundwater. I think we have to be aware of that. So it's all around that this has to happen. And there has to be a linkage between the different levels. I think that's maybe where we are missing out quite a bit. So there's a sphere, you can say, at the local scale around groundwater use, because groundwater is oftentimes used at a small scale in villages with individual wells and so on, and there can be maybe conflicts between one well user and another well user. So they can be very small and local issues. And then you can have issues that are at a much larger level, where we're talking about transboundary and regional aquifers. And of course, the issues there will be quite different, but nevertheless very important. And especially in these times with climate change and increasing demand, the countries are looking towards their transboundary aquifers. And so we need to understand them as well. We need to bring them into our negotiations around water sharing and understanding both surface water and groundwater in conjunction, not separately, and coming up with the sharing rules and so on that relate to both surface water and groundwater that are functioning. And then also having, representatives of local communities and decision makers involved in these regional and transboundary discussions. I think that's oftentimes missing. We have like two spheres that are a bit separate. I think we can do a lot more there to have a good representation from all spheres and from all levels, and from women and from, to make those informed decisions about groundwater. Thanks.
Great. That was a lot. Thank you, Karen. And Jay, do you want to add?
Looks like Jacques had his hand up.
Thank you. No, I would like to add that groundwater governance and water governance generally is the mother of all possible solutions to increase resilience of water use. And we have explored this issue in a book together with Jean-Fried about hydrogovernance. And of course, this is a multi-level process. There is a kind of need to link what is the policy and governance at the local level at the region and national level. Also, if we speak about transboundary aquifers at international level. But what is important in this is the political willingness. And sometimes politician doesn't care about invisible water because of many reasons. For example, data are very expensive. The time scales are very long for their, say, political career. So it takes 2 times. There is no something to, say, celebrate as an achievement, as a technical, say, structure. So there is a problem how to understand by also the society that groundwater is important. And of course, there is a lot to do with capacity building, education, and educating also the people and the local stakeholders. Thank you.
Thank you very much.
Thank you, Jacques, and thank you, Mary, for moderating this question and answer period. I think we'll have to wrap up now. And this has been a fascinating session. Thanks to all of you, and thank you to our participants as well for staying with us during this opening session of our groundwater conference. I think that we're going to show the schedule for the next 2 days now. And I want to remind everyone that all of the times that will be indicated are in Central European time, with France as the reference, since that is our headquarters. And recall that Central Europe changed its time last weekend. So it's now, it fell back for the winter time. So if you're trying to figure out what time a session is, please be sure to check your time zone and the difference in the time zone. I also want to remind you that we are going to record the sessions and that the recordings will be available online. And we also have a lot of fascinating posters that have been submitted. The posters are available at the conference website under posters. If you have any questions on those posters, you can send an email to online.conference@iwra.org. And we will contact the poster authors to respond to your queries. And in addition, unfortunately, we couldn't answer all of the questions that were posted today, and we won't be able to do that throughout the conference because we chose to use time to present content. But we will be looking at all of the questions and asking the authors of the sessions and the speakers for responses, and the questions and answers will then be posted on the conference website. I think that's it for now. So we'll wrap up. Thanks again to everyone. And we look forward to the conference over the next 2 days. Take care.
Thank you, Renee. Thank you, everyone.
Thank you, Renee.
Thank you, Renee.
Thanks, everybody.
Thanks, everyone.
Bye.
Thank you.
Bye-bye.
Bye.
Bye. Bye.